Okay, guys, question number 3 is what we will be looking at in today's lesson. I'm just hoping that I won't spend much of our precious time on this question. But remember, guys, most importantly, what I'm going to be doing is just to take you through the given statement, the given diagram, and lastly, we have a look at the question. So, what I'm going to be doing is to guide you in terms of how you answer those questions. So, question number 3 is what we will be looking at in today's lesson. So, let's see. Let me just check if I can be able to write. Yes. So, this is the statement that we are given, and I'm going to quickly read through that statement. So, it says in the diagram below, P being a point having the coordinates 7 and 4. Where is P? Okay, there is P. Q being a point having the coordinates 6 and 6. Where is, okay, there it's Q. R being a point having the coordinates 0 and 3. Where is R? Okay, there is R. And S being a point having the coordinates T and K. There is S. And the statement continues to say, are the vertices of quadrilateral PQRS. So that means in this case, we are dealing with a quadrilateral having 3 known points and 1 unknown point, being point S. So, very quickly, let's try to have a look at the questions. I think I'm going to quickly assist you with those questions. So let me just scroll up. I think we've got enough information from that statement. We can just refer to that diagram. So this is a total of 16 marks. So let's see if we can possibly score all the marks under this question. 3.1, it says, calculate the length of PQ. Leave your answer in SAT form. Good people, the key word in this case, what they want you to do is to calculate the length of PQ. Where's P? Okay, there is P, and then there is Q. So that is the length they want you to calculate. And most importantly, they want you to leave your answer in SAT form. What you need to remember, honorable members, let me quickly use a different color for that one. What you need to remember is that when it comes to the length in mathematics, length or the distance, we use that formula that we know, which says a square root of, what is it? Obviously x2, you minus x1, you close. This is a mistake that you normally make. You forget to square that. Then you need to plus, and again, you can still do all of this correctly. But possibly you forget to square that. You can either forget it when you write down the formula or when you punch it on a calculator. So this part, it shouldn't confuse you guys. It simply says leave your final answer in a form of a square root. It could be a number, then square root. So after you substitute, you work it out to its simplest form. Do not write it as a decimal, but in a form of a sort. So that's how you answer that question, and you score yourself 2 marks. So I'll just remove all of that as we look on to the next question. So let's see. The next question says, if, this is the question that I'm looking at, if T, which is a point, it has this coordinates 7/2 and 7/2. If that point is the midpoint of QS, where is Q, where is S? Okay, now I see. There is Q and there is S. Determine the coordinates of S. Let's try to do something there. Maybe let me look for a different color. So what examiner is saying is that if T, can you see now a new point has been introduced. So you need to locate where that new point is, being T. So this is what guides you in terms of exactly where that point is. It is in the middle point of QS. Maybe let's try to construct a line from Q to S. So that means that point T, it's actually somewhere there. I'm just giving an estimate, because what I know is that that point has to be in the middle of QS. Because examiner mentioned the middle point, that means this is where you might need to use the midpoint formula. This is where most of you guys struggle. So let me quickly remove some of the information there just to create myself a space to try work it out. Let's see. I think it's fine. So let's see. Obviously, the formula for the midpoint, it says when you calculate for the x value of the middle point, of which in this case we know the middle point is T. So let's say the x point at point T, it has to be equals to, you need to take the x value of the other point, which could be a Q. You need to plus it with the x point at the other, the x value at the other point, which is S. Then you need to divide that by 2. And then you do the same for y. Maybe let me use this side. So you're going to say y, obviously at T, it has to be equals to, let's see, a y at Q. There you say you started with Q. So also here, let's follow the same. So it's going to be y at S, then you need to divide it by 2. So the most difficult part is where you now need to substitute. So this is how you substitute. You know that point T, it has the coordinates 7/2 and 7/2. And this is the middle point. So can you see? You have that known point. You also have that known point. This is the unknown point that you are looking for. And if you remember, I've always been saying analytical geometry, it's a game of two things, which means you need to know 2 points or 2 things in order to calculate the third unknown. This is how you substitute. What is the x value at the middle point? This is the x value that you substitute. That one there. What is the x value at Q? This is the x value at Q, being 6. So can you see? You are therefore going to cross multiply, and then you take this to the other side. That's how you calculate for that. You do the same here. What is the y value for the middle point? Obviously, the y value there, it is that one. And then now, what is the y value of the Q? The y value of that point is obviously 6. Then for you to calculate the y value at S, you cross multiply and then you take this to the other side. So that's how you calculate y at S. So just be careful and make sure that you substitute correctly, and most importantly, you follow MES procedure to work it out. So I think let's quickly jump on to the next question, but you might need to remember the calculations that you are doing. So what I'm saying is, what we just calculated, we might need it in the upcoming questions. So let's not forget what we calculated. Maybe for now, let me try to construct that line again. Okay, this is that point T that we calculate. Not calculated, but we know about that point. We calculated S. So now 3.3. If the coordinates of S are 1 and 1. The nice thing about this type of a question is that on your previous question, you must have possibly got 1 and 1. So now they want you to show that PR is equals to QS. Where is P, where is R? There is P, there is R. Where is QS? There is Q and there is S. So normally when you show that PR is equals to QS, this is what you'd normally do. Remember guys, they said this is a quadrilateral, which means this side is parallel to that one, and it's also equals to that one. The same here, that parallel to that, and also that equals to that. Meaning the diagonal line, so that means from P to R, it will be equals to Q2S. And when you show that, you can use the distance formula to say the distance from PR it's equals to the distance from QS. You use that same formula that I explained. So try to work it out and see if you are going to get the same answer as the distance for those. So I think that gives you an idea of how you work it out. So very quickly, let's look at 3.4. I notice I'm running out of time. I've actually spent 13 minutes on this question. I'm hoping to finish it in less than 15 minutes. So that means I'm actually left with almost 1 minute, but it's fine. Let's see how far we can go with that. 3.4 show that QR it's perpendicular to RS. Where is Q? Okay, there is Q. Where is R? There is R. So this is the QR that examiner is talking about. They say we need to show that it's perpendicular to RS. Where is R? Where is S? There you go. So remember, when you have perpendicular lines, they form a 90 degree, which means when you multiply the gradient of QR by the gradient of RS, they need to give you -1. So that means you need to calculate the gradient of that line and the gradient of that line, multiply them together, and if they give you -1, that's how you have shown that QR is perpendicular to RS. Very, very much important, ladies and gentlemen, on that one. So very quickly, let's move on to the next question. I think you now have an idea of how to work out that question. So let's see. a question 3.5. Hence, what type of special quadrilateral is PQRS? Motivate your answer. Very, very much important, ladies and gentlemen, that at all the times you pay full attention to all that you learn at school. So for this question, I'm just going to give it to you, because obviously whatever that I say, it will be an answer to that question. So I think I won't spend much of our precious time on that one. So just make sure that you remember what we taught you in class. Otherwise, if you can't remember, just make sure that you attend the next live lesson where we will be doing some calculations on this question. So the last question, 3.6, it says, calculate the size of angle S in triangle RSQ. Let me quickly indicate something very much important to you guys. Calculate the size when something is written in this format. There you are having RSQ, and they do that. So this is how you read it. You say a angle S in triangle RSQ. So that means in triangle R, where is R? There is R to S. No, not there, but to Q. Yeah, I'll need to redraw that. So let's see. RSQ. So it's more like from there then to there. Can you see? This is the triangle that examiner is talking about. And the angle that they want you to calculate, it is that one being angle S. Something interesting. You did show that you are having a 90-degree angle there, which means you are having a right angled triangle. Very, very much important, ladies and gentlemen, on that one. So obviously, since you are having a right angled triangle, that means you can use the trig ratios. What are those? It is tan, sine, and cos. So you have enough information there. You just need to be having two distances or two known lengths. I think, let's see. I think we did calculate the length of a QS. If we did not, then you might need to calculate that. I'll just give you guys an example. Maybe let me not write a number, but let's say we calculated QS and the distance there, it was let's say D for Desmond. And then now, let's say we calculated the distance of QR, and let's say that was maybe 8. Yeah, let me just give a number then, say 8. And then if you calculate RS, maybe let's say you find it to be 4. I'll just use the number so that it makes sense. So that means now you're going to ask yourself this question to say, which trig ratio will be suitable for you to calculate that angle at S? If you use tan, you must be having the side which is opposite to that angle over adjacent. If you use sine, you must be having opposite and hypotenuse. If you use cos, you must be having adjacent and hypotenuse. Then that's how you calculate that angle there. So guys, I think I've actually given you enough information to work out that. So for now, I will just leave it there and say good luck on that question. So, ladies and gentlemen, as always, I do thank you very much for joining. My name is Desmond, and I'm out.